Welcome to Chillin' 101. We hope this video helps.
You begin by assembling the optical path, a stable light source, a clear sample, and a precise protractor or goniometer. Measure the incident angle and the refracted angle carefully to 0. 5 degrees. Once done, note the light wavelength and ambient temperature. Use air as your reference medium and record its index if high precision is needed. Make sure to eliminate reflections and align the detector so the measured refraction is only due to the sample, not stray beams. You now apply Snell's law directly. N1 sin theta 1 equals N2 sin theta 2. Substitute the measured angles and the known N1 for the reference medium, then rearrange to solve N2 equals N1 sin theta 1 slash sin theta 2. If you need absolute refractive index from speed, measure light speed in the sample and compute N equals C slash V. Remember why this works. The sine ratio encodes phase velocity change at the interface, and wavelength or temperature shifts cause measurable index changes, so correct for them when needed. You finish by repeating measurements and averaging to reduce random error, report the mean and a simple uncertainty estimate. Verify your arithmetic in units, and make sure angles were converted to radians only when needed in formulas. Most Snell calculations use signs of degrees directly. If results disagree or look non-physical, recheck alignment, beam collimation, wavelength stability, and whether the sample has gradients. One key troubleshooting tip: realign the source and detector first. Most systematic errors come from misalignment.
Thanks for watching. Consider subscribing if we helped you.